All right. So, hello, my dear friends. How are you all doing? I hope you are all doing wonderful. Right. So, welcome back to this particular session on today's discussion. So, we are back again with the JEE mains question revision practice session. Right. So, we are going to discuss the previous year questions, and along with the previous year questions, we are also going to recap the important concepts. Right. So, today we have a new topic with us, and the topic is basically functions. Right. So, today we are going to discuss the topic of functions. And as you all know that function is one of the very crucial chapter for starting the part of calculus, right? So especially for studying calculus, the function is especially very important, right? So today we are back again with this session. So with this back an important session on functions, right? So we are going to discuss the all the important previous year questions on JEE mains for the topic of functions, right? So before we start for this particular session, as I like to repeat in the previous classes, right? And I hope you are also following the same. So before coming to this particular class, I hope you have done quite a bit of revision, right? So what all things you need to do is basically before you come to this class, you have to basically go with the basics from the NCERT textbook. And once you're done with the basics in the NCERT, you have to go and solve the NCERT exemplar problems. At least for the time being, you have to do this particular job, right? And once you're done with this particular NCERT and NCERT exemplar problems, you have to basically start making notes. You have to start making short notes, right? Because short notes will actually help you up for your revision. This will be for quick recap, okay? So it is basically for revision before the exam. And once you're done with doing that, you can directly move on to solving the previous year questions, right? I hope this part is clear to all of you. All right. So once you are done with doing that, then you can definitely start watching this live session, right? So we are live on this particular topic of functions, and in today's session, I'm going to show you what are the different types of questions that has been asked in the JEE Mains previous year questions, right? Now, when you basically need to understand the topic, what you need to understand is that first of all, if you're done or clear with the basics, then if you try to understand one or two simple questions from the solved examples, you can definitely try to get most of the examples or most of the questions that I'm basically solving for today's class. Okay. Now, so today we are basically going to discuss everything, and we covered the important JEE Mains question, right? So let us start with today's session. So I will be the instructor for this particular course, right? So we have already discussed this JEE Mains previous year question, right? And previously we have started discussing on the JEE Mains previous revision series, where we are discussing each and every day some different topics of maths, and in each of these different topics we are basically solving some important previous year questions, right? I hope this part is clear, right? Now, and if you are new to this particular channel, don't forget to hit the subscribe button, and don't forget to leave a like if you love this particular effort that has been conducted by me. And we are basically trying to build the better content on YouTube, right? So that it is available for everyone, and that is basically helping you out for your preparation. I hope this part is clear. Okay, so with this part, let's start our today's discussion. So if you are new to this particular channel, don't forget to hit the subscribe button, and you can always join the Telegram channel from the link in the description. Okay, so you can find the link of the Telegram channel in the description, because all the lecture materials, short notes as well as mock tests will be shared in the Telegram channel itself, right? And it will be a very beautiful opportunity to connect with me on the Telegram channel. All right, but so with this part, this I hope this part is clear to all of you, right? So let's start our today's goal. So today our goal is basically to discuss about the concept of functions. We will also discuss some of the previous year questions. All the previous year question of JEE Mains. We'll practice both numerical type and MCQ based questions, and we also practice. We'll try to understand what are the types of questions that has been asked in the JEE Advanced, and especially from the integer type, and as well as or single correct type, right? And we will try to predict the paper pattern, right? So let me quickly share you the statistical result that I have got while I did the statistical analysis on the previous year questions, right? So if you look at the previous year questions, okay, and if you look at the every year pattern, so on 2024, so in the 2024, the data are something like this. All right. So the results are as follows: that in 2024, the weightage was simply around, it was simply around 3.67%. So you can roughly estimate that is basically equals to one question. And 2023, the weightage was around 3.75%, which is again roughly around one question. And 2022, the weightage was around 3.04%. So therefore it is another one question. And in 2021 the weightage was around 2.69%, right? So 2.69%, and which basically around roughly estimate for 0.9 question or one question, right? So if you just look at this data, these data are very misleading, right? So if you must be thinking that there are very less question that has been or that has been asked in every paper, right? So that doesn't make us stop from discussing the chapter of functions. Now I will tell you this function is very very important because this is one of the guiding stone or the pillars. Okay, it is one of the pillar to learning calculus. Okay, so therefore this particular chapter is very very important and crucial. Okay, so it is one of these pillars to learn the calculus. Okay, and you know the calculus is the most scoring and most high weightage topic of mathematics, especially for your JEE mains as well as JEE advanced examination, right? And if you look at your other state government examinations, the numbers are also the same. Okay, so that will suggest that basically the weightage was more or less around this number only. So you can at least expect that that there will be roughly at least one or two questions that can come up from this particular chapter. If not directly the question from function, it might be asked in some other way, right? It might be asked in a type of a question from applications of derivative, or from limits, or for continuity and differentiability, or maybe from the questions of integrals, right? So those particular thing, now keeping those things in mind, we need to study functions in very detail, right? And especially the topics of functions that you need to understand very detail or in a very detailed way is basically the concept of domain and range, because ultimately in calculus when you are going to differentiate or integrate, you are basically going to have an idea of what is a domain and what is a range. Without knowing the idea of domain and range, you cannot solve for the question, because if you don't know what is the input of the function, then you cannot put anything into the function, right? So that's what the condition is, right? So let us start our discussion on the very first problems. Okay, so this is the very first problem of the JEE mains, right, on the topic of function. Now I would request all of you, if you have done a substantial amount of revision and you're done with this practice of the concept, so please try to solve this particular problem. Okay, so this question is a very simple problem. We just need to find out a domain for the two different functions, and from that we are going to predict the values of alpha, beta, gamma and delta, right? So if you look at this particular problem over here, so let us consider this particular first function as function f of x, that is basically given as log of 18x minus x square minus 77 base 5, right? And it is said that the domain of this, the domain of this function f of x is alpha comma beta, is given as alpha comma beta on the open interval, is given as alpha comma beta on the open interval, right? So that is basically mentioned about the domain of this particular function, right? Now if you recall from the basics that whenever we have a logarithmic function, the condition is that the x should be greater than 0, and the base should be also greater than 0, but it should not be equals to 1, right? So here the base is basically is 5, which is greater than 0 and not equal to 1, so therefore there is no condition on that, but the condition is this particular quantity should be greater than 0, right? So let us try to equate this particular quantity greater than 0, and let's see what's the number we are getting. So if I try to equate 18x minus x square minus 77 to be greater than 0, then it's basically a quadratic inequality, right? So therefore we will have x square minus 18x plus of 77 will be less than 0, right? Just I change the sign, and from here this is basically a quadratic equation, right? With the, so I can just factorize this part out as x minus 7 and x minus 11, which is less than 0, right? So from this inequality we will have the x to be lying between 7 comma 11, right? So therefore this is going to be the domain, right? So let me write it over here. The domain part is basically x belongs to 7 comma 11, right? So from this particular part we are having the value of alpha as 7 and we are having the value of beta as equal to 11. I hope this part is clear and making sense to all of you, right? So now we have to basically find the domain of the next function, and let us call this particular function as some g of x. Okay, let us call this function as g of x, right? So if we look at this particular function, again it is a logarithmic function, it's a log function. So g of x is basically log of 2x squared plus of 3x minus of 2 divided by x squared minus of 3x minus of 4 and base x minus 1, and its domain is, and the domain of this particular part, and the domain of g of x is basically given as gamma comma delta, right? So from this, again, if the condition is x minus 1 should be greater than 0 and x should not be equal to 1, right? And along with that, this particular expression 2x square plus of 3x minus of 2 divided by x square minus of 3x minus of 4, this particular part should be greater than 0, right? Now if we try to simplify this particular part, we are going to have 2x minus 1 multiplied with x plus of 2 whole divided by x minus 4 into x plus 1, that should be greater than 0. Now we will apply from this particular part, we are getting x should be greater than 1 and should not be equal to 1, so therefore x should be greater than 1, and from this particular part I will use the Wavy-Curve method. So from the Wavy-Curve method, just I will plot the critical point. So the critical point is going to be minus 2, minus of 1, which are the corresponding roots of the given factors, right? So these are all the critical points, and then I see the first coefficient of x is basically the positive, right? So I will start with positive, minus, positive, negative, positive, right? So from this I need to obtain only the values of x for which and the region is positive, right? So therefore your x should be between minus infinity, but since x should be greater than 1, so I will be only interested to find out the number which is greater than 1. So therefore our inequality will be x should be greater than minus 1 to, extremely sorry, so it should be basically between 4 to infinity, right? So it should be between 4 to infinity. That's what the solution, that's what the inequality is, right? So therefore if we take the value of x to be greater than 4, then only we are getting the condition satisfied. So it is going to be 4 to infinity, right? And in this question it's mentioned that is gamma comma delta. So gamma is basically equal to 4 and delta is infinity, and ultimately we have to report for the value of alpha square plus beta square plus gamma square, and that is nothing but it's simply going to be equal to 186. It's going to be 186. So from this we are going to have the correct answer for this particular problem as option number A. I hope this part is clear to all of you. Please let me know if this is clear or not. Please let me know if this particular part is clear or not. Okay, so very simple problem. We just try to find the domain of it, right? So if I recall, what is the definition of domain? Domain is basically that particular set or interval of x for which the function will have a defined output, right? So whatever values of x we can put inside the function to get a defined output, that is what is called the domain, right? And once we satisfy all the important properties or the way the function is defined, we basically try and find out a domain. Very simple, right? Now students basically need to ask this question that, do we have to remember this, that for log function this particular thing must exist? This is nothing to remember. It's obviously defined in the following way, right? But it is nothing to like remember in that way. In sense, I mean to say that when you keep on solving questions or questions of different types, you will automatically get adjusted to solving this particular type, right? And automatically things will get remembered. Okay, so that is what I am basically trying to tell. Okay, so I hope this particular part is making sense and it is clear to all of you, right? Please let me know if you are also getting the answer as option number A. Please let me know if you are also having the answer as option number A. All right. So I hope this part is clear to all of you and is making sense to all of you, right? If you have any questions, you can definitely put that on the live chat, okay? And if you're watching the session after the live session is over, you can always post that question in the comment section, okay? I will be looking for your doubts in the comment section and I will love to answer your questions, okay? And if you want to get personal doubt clearance, you can definitely join the Telegram channel, right? Because in that case, I will be sharing the handwritten solution if you have a very difficult problem and you're not able to solve it, right? So that is basically what we need to discuss in this particular problem, right? So that is clear. Is this part clear? Please let me know this part is clear or not. Okay, if it is not clear, I will repeat it again. Please let me know this part is clear or not. I will repeat it again if something is not clear. Okay, so I'm expecting the parts are clear and they are very simple, right? So once you apply the formula and once you recall the properties, then the things are clearly simple, right? So with this part, let's move to the next problem, right? So again, we have a questions basically based on the function type, right? Now these types of questions are also very important because in the questions of functions, you will also see that the type of functions, that is one function or onto function, are also frequently asked in the JEE mains, right? So therefore this is a important thing that you need to discuss, right? So let us try to understand how we go about solving this question, right? So in this problem, it is mentioned that a function is having the domain 0 to 3 and it is going to the codomain set A, which is defined by the function f of x such that it is basically 2x cube minus 15x square minus 15x square, alright, plus of 36x plus of 7, right? That's what the definition of the function f of x is given as, right? And it is said that, and also there is a function g of x which is defined on the domain all the positive real numbers and going to the set B or codomain B, and is defined by g of x such that this is given as x to the power 2025 divided by x to the power 2025 plus of 1, right? That is what is mentioned in the problem, right? And it is said that both the functions are onto functions. Both f of x and g of x are onto function. Okay, both f of x and g of x are given as onto function. That is what is mentioned in the problem, right? Now it is said that if x belongs to integers, we have to talk, and x also belongs to a, or x belongs to b, then we have to recall this is basically the set defined as S. Now we have to basically find the cardinality for this particular set. Now n of S basically means for cardinality or the number of elements in the set, right? So I'm writing it up. So this basically means as cardinality. Okay, cardinality of set S. I hope this is clear and making sense, right? So now how do we proceed for the question? So what do you basically mean by onto function? Onto functions are those functions, onto functions, onto functions are those functions for which we will have that codomain is equal to the range. We will have the range to be equal to the codomain. Will have the range to be equal to the codomain, right? So these kind of functions are known as onto functions. So onto functions are those functions for which we have the range to be equal to the codomain, right? So once we get to the range of the f of x and g of x, we will say that it is equal to a in order to the function to be onto function, right? And from that we can find out for the number of the elements in the set S, right? So that's what our task is, right? Now if a function is onto function, then it is basically need to be an increasing or either a decreasing function, right? In order to cover the end. So basically what we need to understand that the range should be equal to codomain. Now how do we calculate for the range? The range is simply calculated by finding out the maximum bound and the minimum bound, right? So once we find the maximum and the minimum bound of a particular function, then we are basically getting the range of the entire range of the function, right? So let us try to do the same thing over here. So for the function f of x, if we try to find f dash of x, over here, it is going to be 6x square minus 30x plus of 36. That is what is mentioned, right? Now this is going to be equal to 6 times of x minus 2 into x minus 3, right? So if you just look over here, this particular function is basically having two critical points, x as 2 and x as 3, right? And similarly 0 and 3 are also the given interval of the domain, right? Now in this 0 and 3 domain, we have to find for the maxima and the minimum, right? So if I try to find the value of function at 3, I will get this part as 34. And if I find the value of function at 2, we are getting it as 35, right? And similarly, the functional value at x is equal to 0, I'm getting it as 7. And similarly, the functional value at x equal to 3, we have already found it out, right? So that's what the points are, right? Now from here, if you see that the maxima and the minima are equal to 35 and 7, right? So therefore the set A will basically start from 7 and will go to 35. That's what the set A is, right? That is what the set A, right? And similarly, following the same logic, I will also try to find out for g of x, right? So if you look at g of x, it is basically defined as follows. Right, this part is clear. Now from this part, we can also write this part as 1 plus 1 upon, sorry, 1 minus 1 upon x to the power 2025 plus of 1, right? That's what we can also simplify and write this up as, right? Now since your x for this g of x function, your x is basically all the positive real numbers. It is defined as all the positive real numbers. So therefore this part is going to be all the positive real part, right? So 1 upon this part is going to almost approach towards 0, right? So therefore this part maximum will go to 1, right? This part maximum will go to 1. So from this part, our range of this function g will maximum go to 1, right? And if you look at, and if you start with x equal to 0, it is going to be equal to 0. That is going to be minimum point, right? So the range of this particular function is going to be 0 to 1. So therefore this is basically equal to, so set B, right? Now, if we look at only the integer element, your set A will consist of 7, 8 and so on up to 35, right? And similarly, your set B is only consisting of one element, that is 0, right? So if you just count for all the number of elements in the set S, that is basically combining of the set A and B, it is going to be equal to 30. It is simply going to be equal to 30 because there are 29 elements over here and this is a one element. So that is going to be equal to 30. So therefore, the cardinality of this set S is equals to option number C. I hope this part is clear to all of you. So that is going to be the correct answer for this particular case. Is this part clear? Is this part clear to all of you? Is this part clear to all of you? Please let me know. I hope this part is clear to all of you. I hope this part is clear to all of you, right? So once we are done with this question, shall we proceed with the next problem? Shall we proceed with the next problem? Please let me know. Please let me know in the live chat. Can we proceed with the next problem or not? This problem was fairly simple and straightforward, right? I'm assuming that you are able to understand this problem, right? So the question is very simple. You have to basically try to remember the basic concept, that what is the concept behind the onto function. And also you need to understand how to find out the range of any particular function, right? So once you know this particular part, then the question is very, very simple, right? The question is very, very simple and straightforward. Okay. So this part is clear to all of you. So let's proceed with the next problem then. So next problem is a very interesting problem, and please star mark this problem. Okay, this is a J advanced problem that has been repeated many times in your JEE mains. Okay, this is a J advanced problem but has been repeated many times in JEE mains, right? So let me tell you the problem of type. So whenever you will have the problems of this particular type, that is whenever your functions are defined as some a to the power x divided by some a to the power x plus some constant, right, like this, or maybe some constant b, then if you look, there is very interesting property over here, that is you find out excuse me. So if you find out f of 1 minus x, it is going to be equal to a to the power 1 minus x divided by a to the power 1 minus x plus of b, and if you try to simplify this part and then you find out the sum for f of x plus f of 1 minus x, it is going to be simply equal to 1. It is going to simply equal to 1, and that is a very, very interesting and a beauty of this particular problem, and that is a very much important beauty of this particular problem, right? So we are just going to use or utilize this particular beauty in order to solve for this question. So if you just look it over here, so over here, if you try to find it out, the function value at 1 minus x, it's going to be equal to, 2 to the power 1 minus x plus of square root of 2. And if you try to find the summation of f of x plus f of 1 minus x, this value is going to be equal to, this particular value is going to be equal to 2 to the power x divided by 2 to the power x plus square root of 2 plus 2 to the power 1 minus x divided by 2 to the power 1 minus x plus square root of 2. And if you just try to simplify this part, right, which is very simple to simplify, so you can just simplify this part out and you will see that this particular value is going to be equal to 2 to the power x plus square root of 2 divided by 2 to the power x plus square root of 2, and that is basically is equals to 1, right? This and this going to cancel, and therefore we are having the summation of f of x plus f of 1 minus x is going to be equal to 1, right? Now ultimately we have to basically look for the summation of, k1 to 81, right, and functional value of k by 82. Now if you just try to expand this, it is going to be f upon 1 upon 82 plus f upon 2 upon 82 and so on up to f upon 80 80 by 82 plus f upon 81 by 82 plus f upon, so that is it, right? That is it. So if you just look it over here, and the middle term, for this particular summation will be f upon 2, f of 2, right? Because if you put sorry, f of 1 by 2, right, 1 by 2, because if you put k is equal to 41, it is going to be equal to 1 by 2, right? Now interesting part over here, if you try to find the summation of the first and the last term, if I try to find the summation of the first and the last term, it is going to be equal to 0, right? This particular sum for the first and the last term, it is equal to 0. Similarly, the second term and the second last term, again if you try to take the sum of it, it is again going to be equal to 0, right? So that's how you make the pair. So that's how you make the pair, and you will understand that there are a total of 40 pairs. There are a total of 40 pairs, where you will have the answer as 1, and unfortunately there will be one particular term which will not have a pair, and that is basically f of 1 by 2. And for f of 1 by 2, we can always put that back in this particular equation, and if you find out that f of 1 upon 2 is going to be simply equal to, so f of 1 upon 2 is going to be simply equal to 1 upon 2. You can just check it. It is basically going to be equal to 1 upon 2, right? So from here, this particular summation is going to be 40a plus 1 upon 2, and that is basically equal to 81 by 2. That is basically equal to 81 upon 2. And so from here, we will see option number D is going to be the correct answer for this particular problem, right? I hope this part is clear to all of you. Now, please make sure that you recall this question before you are going for the quick exam. If you don't recall this particular type of problems, then it is going to be very, very difficult while you solve the actual paper in the examination. Okay. Now, this property is a very special property that holds for this kind of function. Okay. So, whenever you see the construction of the function in this way, make sure that you recall this particular property. Okay. Is this part clear? So that's why I'm marking so many stars, okay, to make sure that you actually recall this particular question before you are going for your actual examination, okay. So please make sure that you recall these questions before you are going out for your actual examination, all right. So please let me know this part is clear or not. Please let me know this part is clear. Is this part clear to all of you? I hope this is making sense, right? So we are trying to discuss all the important questions, right? And you can see that this question is very, very important, okay? And this particular property is especially very, very important. And if you look at previous year problems, you will see that there are a lot of times this type of questions has been repeated. Yeah, hi Techie Alpha. Hi Techie Alpha, how are you doing? Is it clear to you, Techie Alpha? Is this part clear? Wonderful. So, okay. I hope this is making sense to all of you. And so if you're done with this solving this question, so let us proceed with the next problem, right? I hope this part is clear. Shall we proceed with the next problem? Okay, so proceeding with the next problem. So next problem is again an interesting problem which is defined by the following function. Okay, and there is a functional equation also given with the particular function definition, right? So from that particular functional equation that is mentioned, you have to basically talk out for the value of the f of I, or the modulus value of I, and you take the summation from I is equal to 1 to 5, and that is what you have to do in this particular problem, right? So let us see how we try to solve this question. So let us try to see how we try to solve this particular problem, right? Now this is going to be an interesting problem. If you just look at the problem construction, it is said that the function f of x is defined as 3a plus of 2 x squared plus a plus 2 divided by a minus 1 into x plus of b, right? And it is said that a is not equal to 1, and the functional equation that is given for the function f of x is basically f of x plus y is equals to f of x plus f of y plus of 1. That is what is mentioned, minus of, sorry, plus of 1 minus of 2 by 7 times of x into y, right? That is what is mentioned in the problem, right? Now we have to basically go about to find out the integer value, right? Now interestingly, if you try to solve this type of question, now you have to get some idea. Now whenever functional equation questions are given, what I generally recommend student is basically try to find out especially the value by putting x and y equal, to some 0, right? And try to figure out that what kind of situation you are getting, and from that you can try to generate a recursive relation, right? So let us try to see how we do that. So if I put x is equal to y is equal to 0, that is basically f of 0 is equal to 2 times of f of 0 is basically equal to 2 times of f of 0 plus of 1 minus of 0, right? So from here interestingly you will find f of 0 is equal to minus of 1. From here interestingly you will find out f of 0 is basically equals to minus of 1. And if you try to do that f of 0 minus of 1, that means if you put x is equal to 0 from here, you will get this b value is coming out as minus of 1. This particular value of b is coming out as minus of 1, right? Now this 0 can also be approached. Now this particular 0 can also be approached by putting x is equal to minus of y, right? So f of 0 is equals to f of x plus f of minus of x plus of 1 minus of 2 by 7 x square. So there will be plus over here, right? Plus of 2 by 7 x square, right? Now this f of x plus f of minus x, I can just put it from this particular function value over here and try to check out. So f of 0 is basically equal to minus of 1, and f of x plus f of minus of x, it is basically the odd term is going to cancel out. odd term is going to be cancelled out. So therefore, we'll have 2 times of 3a plus of 2 x square plus 2 times of b square plus of 1 plus of 2 by 7 x square. That is what we have. That is what we have. Now we'll just put the value of b over here and we try to solve for it. And we try to solve for this particular quadratic equation over here. Is this part clear? So if we try to solve the quadratic equation, the quadratic equation is something like 2 times of 3a plus 2 multiplied by x square plus of, or let us take 2 by 7 inside this, so that, so plus of 2 by 7 whole multiplied with x square plus of 1 minus of 2, so that is going to be equal to minus of 1, right, and is equal to minus of 1 over here, right. So simplify this part, it is going to be 6a plus 4 plus 2 by 7 plus 2 by 7 is equal to 0, plus 2 by 7 is equal to 0, because if you just try to compare the coefficient of x square should be equal to 0, the coefficient of x square should be equal to 0, in order to this 1 it should be equal to 1, right. That's how simply I'm doing it. And from here you will get the value of a, coming out as minus of 5 upon 7. From this part you are going to get the value of a coming out as minus of 5 upon 7, right. So from this part, if you have the value of a and b, you can now completely define the value of the function f of x, and that is going to be 1 upon 28 4x squared plus 21x plus of 28, right. That is what we have, and if you put a mod of it, so there is going to be a mod of this over here, because we have to basically find for the summation of I going to 1 to 5 mod of f of i and multiply with 28. So 28 is given just to cancel out this particular constant, right. So that is going to be equals to f of 1 mod of f of 1 plus mod of f of 2 and so on up to plus of mod of f of 5, right. And 28 is getting cancelled out, so that is going to give out the answer as 675. This is going to give me the answer as 675. Okay, you just try to keep the values and you sum for it, you're going to get the answer as 675. Okay, I hope this part is clear. So from this you will see that option number b is going to be the correct answer for this particular problem over here. Is this part clear? To all of you? Is this particular part clear to all of you? Please let me know this part is clear or not. Okay, so this part is fairly very simple, right. So once we know how to find out the values of the functional values from the equations or the functional equation, we can simplify this function and we can try to get the values of the constant a and b, and once we get the constant a and b, we can always substitute back to get to the quadratic expression, okay, or the quadratic function. I hope this part is making sense to all of you. Okay, the way I solve this question is the way actually you're going to solve that in the actual examination. Okay, so make sure that you, whenever you are practicing question, you are actually applying the way I am also solving the question. Okay, is this making sense to you? Is this part making sense? Is this part making sense to all of you? Please let me know if this part is making sense to all of you. Right, I hope this part is clear. Okay, so let us proceed now. Let us proceed with the questions. Okay, so I hope this part is making sense to all of you and you are done solving this question, and also you are getting the answer as option number B. Okay, please let me know in the live chat if you are also getting the answer as option number B. Are you also getting the answer as option number B? Is this clear? Okay, if you have any questions, you can always comment, put that in the live chat. Okay, and if you're watching the session after the live session is over, so you can comment that particular question. I will be definitely giving your answers. Okay, so don't worry. The question is very simple. Just need to follow the steps as mentioned. Okay, so please let me know if you have any questions, or else we can proceed in the next problem, right. So let us proceed to the next problem, and next problem is basically a problem where we have to discuss about the type of the function, right. So we have to discuss on, define and comment on the type of the function we are having, right. So the question is saying that we have a function which is defined by the following way. We have the function which is defined as 2 to the power x plus 2 to the power minus of x divided by 2 to the power x, so this is going to be minus, right, plus of 2 to the power minus of x, right. And then it is said that the function is on the defined on the domain minus infinity to plus infinity and goes to the codomain minus infinity to plus of 1. That is what the domain as well as the codomain we are having, right. So once we have this information, we can easily solve for the, first of all, let us try to find the domain of this particular function, right? So if we try to simplify this particular function, you will see that this function f of x can be simply also written as 1 minus 2 by 2 to the power 2x plus of 1 whole square of it, sorry, 2 to the power, sorry, not whole square, I'm extremely sorry. This is going to be like the expression, right? This is going to be the expression. I'm just trying to replace, I'm trying to writing as 2 to the power x plus 2 to the power minus x and plus of, so if you're adding something, you have to minus it, right? So this is the first part, and then minus of, sorry, just yeah, minus of 2 to the power x minus of 2 to the power minus of x. That's how we are writing this particular expression, right? That's how we are writing this expression. And just let me check, this is wrong, this part should not come out over here, so it's just minus of, right, and this is going to be equal to, so we have to make it minus of 2 times of 2 to the power minus of x. That's how we'll get it, right? So this should be plus over here. Fine, now we are actually getting it, right? So that's how we get this particular relation. So once we have this particular relation, we can simplify, write this like this way, right? And now let us check out for the domain. Now in order to find the domain, before we find out the domain, let us try to analyze. Let's try to, so if you just look at this particular function over here, you will see that the domain is going to be all the real numbers, right? Because there is no values of x for which I'm having function to be non-defined, not defined, right? So therefore, the domain is going to be minus infinity to minus plus of infinity, right? That is all the real numbers, right? As mentioned in the problem over here. Now, in order to find out the range, I will try to find out the maximum minima. So let us try to differentiate this particular function once. So on differentiating this particular function, I'm going to get the relation as 2 upon 2 to the power x plus of 1 whole square multiplied with ln of 2 into 2 to the power 2x, 2 to the power 2x, and also multiplied with 2. Okay, that's how we have, right? Now, if you just look at the expression, everything is a function which is basically all positive, right? This is exponential function which is always positive. This is a 1 upon square of the function, which is square of the linear term, which is, sorry, the square of the exponential term, which is also a positive quantity, right? So therefore I will have f dash to be greater than 0. I will have the f dash to be greater than 0. So therefore I can comment that f of x is an increasing function. Right? Now once we have this f of x to be an increasing function, we can try to understand that if we put the, so therefore our minimum and maximum value will always occur along the endpoints of the domain, right? End points of the domain. Okay, will lie along the endpoints of the domain, right? So from here, if you try to put the function value at f of minus infinity, now remember one thing, that whenever infinity is not a number, right? Infinity is just a concept. So when you have to put or substitute for x equals to minus infinity or plus infinity, you will take the limit. Extending to infinity or extending to minus of infinity. That's how we get to the value, right? So if you just look over here, extending to minus of infinity, that is going to be a very small number, right? That is going to be a very small number over, that is, x is very small number, right? So when x is very small number, this exponential value is going to be a very small number, right? And exponential value very small number plus 1 is going to be a very small number. So 2 upon that very small number is going to be a very, so this particular quantity, this particular entire quantity, when I'm tending this x to minus of infinity, it is going to be equal to 1, right? This particular denominator is going to be 1. So 2 upon 1 is going to be equal to 2, and 1 minus 2 is going to be equal to minus of 1. So therefore, f of minus infinity is going to be equal to minus of 1, right? Similarly, I'll try to find the maximum value, that is, so I will try to find the at value at infinity. So at infinity, if I put it again, so infinity is going to be infinity, right? So 2 upon infinity is going to be 0. So therefore, you are having the value at is equal to 1, right? So at infinity, the value is equal to 1. So from here, the maximum and the minimum. So from here, you get the range as minus 1 to 1. From here, you have the range as minus 1 to 1. Now, unfortunately, this is not equal to the codomain. Now, unfortunately, this part is not equal to the codomain. Okay, so unfortunately, this part is not equal to the codomain. So therefore, this function is not a onto function. Okay, this function is not an onto function, but it is a one-on function, because because it is an increasing function, right? So when it is an increasing function, it is obviously whenever function is increasing or is a decreasing, strictly increasing or strictly decreasing, then it is bound to be a one function, right? So therefore, from this question, from the solution, we find out that the answer is going to be, it's a 1 but not an onto. So from here you will see that option number A is going to be the correct answer for this particular problem. So it is basically 1 but it is not an onto function. I hope this is clear, right? So once you know the basics, you are able to solve this question very simple way. Okay. Hi Vinesh. Hi Vinesh. Okay. Okay. I will explain this one question onto question more. Okay. Can you explain one onto questions more? I have doubt in this. Okay. Okay, Vinesh. See, whenever we discuss about the one onto function, what is the thing that you need to understand? One function are basically such type of map. One function is basically such type of map for which, so for corresponding, for individual values of x1, x2, whatever we are putting inside a domain, it will also have only one particular output in the codomain, right? Only it will have a unique output in the codomain, right? So it is not like the case that a function is going like this and then it is keeping constant and then again increasing. So if it is a constant, then for multiple values of x, I'm having the same values of y, right? That cannot be the condition for one-to-one function. So this is not one function, but this is a one function, right? Okay, so for one function, the function need to be either increasing or either decreasing, right? So if you are able to satisfy this condition that it is an increasing or decreasing condition, so as of the question, it is simply found out that f dash of x is greater than 0, which means that the function is an increasing function. And once we are able to make sure that the function is an increasing function, it is definitely a one function. Okay, so I hope this part is clear. And for onto function, your domain should be equal to the codomain, right? So for onto, the range should be equal to the codomain. Okay, the range should be equal to the codomain. I hope this part is clear. So whenever your range is equal to the codomain, then only it's onto function. And in order to solve for the questions of onto or the range, what is the best thing to do is basically try to do the maxima minima analysis. Is to do the maxima and the minimum analysis, right? So once you have the domain, once you have the knowledge of the domain, you can always try to find out what is the maximum value and what is the minimum value. In our case, the function is an increasing function, so the maximum value will always occur around the endpoints. Maxima and minima will always occur the main endpoints, right? Yes, Vinesh, I'm talking about that only. How to check for onto function. Whenever your range is equal to the codomain, it is an onto function. Okay. Whenever your range is equal to the codomain, it is an onto function. Is this clear? Is this clear, Vinesh? So this part is clear to all of you. Okay. So I hope you will understand that how to solve for the question. Okay. So whenever you have these kinds of question, the best way to check for one and onto is basically to try to do the differentiative analysis, or try to find out the first differentiation. Okay, or the first derivative. And if you are getting it greater than 0 or less than 0, then it is a strictly increasing or strictly decreasing. And once you're having strictly increasing or strictly decreasing case, then you can be very sure that it is a one function. And for onto function check, what you have to do is basically try to find out the range of the function. Try to find out the range by doing the simple maxima minima analysis, right? Maxima minima analysis that you have learned in the chapter of applications of derivative. Okay. So don't worry, I will take up the application derivative part in the upcoming sessions. But if you have, I'm expecting that you must have covered that application derivative part. Okay, before we are actually going out with this particular JEE Mains revision. Okay, so this is a revision session. So I am expecting that you have done that part. Okay, so with that part, let's move to the next problem. And interestingly, I have kept this particular problem to make sure that you recall this particular problem, which is very important. This particular problem. Okay, so if you just see over here, this problem is very similar to the problem that we have solved on the type of f of x plus f of 1 minus x, right? So similarly, here in this case, it is basically the form that is f of x minus f of some a minus x is going to be equal to 1. So you have to find out that particular a, right? Or it may be also possible like a f of x plus a minus x is some constant b. So once you're able to find out this kind of relation, your life is going to be very simple in order to calculate for this particular expression. Okay, so I hope you will try to solve this particular problem and let me know the answer you are getting in the comment section. Okay, so this is a homework problem. So please let me know the answer. Please let me know the answer in the comment section. Okay, please let me know the answer in the comment section. I hope you are able to solve this particular part because this is going to be very simple. You just need to do the analysis that I have done and sort it over here. Okay, you just have to do this particular analysis. Okay. So expecting that this point is particularly clear, so you have to do just this particular analysis. Okay, so I'm expecting this particular analysis is clear to all of you. So with this part, let us end our session of the discussion of the important previous year questions on the topic of functions. I hope this particular session was helpful to all of you to understand the basic concepts and the basic questions of the function that can be asked in the JEE Mains, right? So I hope I was able to help you out in your revision, and please make sure that you make short notes and revise it before you are going for the examination. All right. So with this particular note, I wish you all the best and thank you.